right? And I'm just testing the audio, so hopefully that's working too. All right, so I'm going to share the screen, and I'm going to go to the virtual machine. All right, so this is the virtual machine, right? And basically what we want to do is run format, right? Give it the bat file, and we want to get that. You see that? So that's basically the, oh. So it's this, so I'll talk about it. So the book just said return address is what was it? Frame pointer +1, right? But I ended up, having to figure out a way to find it. So I'll show you guys what you can do. And that's why I modified the code a little bit. So the intention was for me to be able to insert the injection in a different way so I could figure out where the return address was located. You guys see that? So so there's a new, in your Brightspace, there's a new file, okay? So in your Brightspace, do I have that here? Yeah. Nope. Hold on. So I think this is also recording. So in Brightspace, I added some files here. And really, because you guys still have to do this, and there's no way that you can literally just copy me. It's a little bit dependent on, I'll be posting this. Right. So anyway, you'll have to kind of repeat this exercise. So I added, so the original file is format 3, right? And then this one is format 5. And really what I added here is a variable that I can put in the stack. I literally intentionally had to put a variable in the stack called buff and then inject through, that code, which is just a whole bunch of characters in the stack to figure out where the return address would be. So I had some reference of that. All right, so I was injecting. So that's why I literally just added, and I'll open this in a second, but I just added a variable and then a copy statement that allows me to overwrite the stack beyond. So I did a buffer overflow basically to kind of. All right, so anyway, so all I'm saying is exploit, it's pretty much the same one you had. I just tweaked it a little. So that's not really that big of a difference. But format 5, I did change it a little bit just so I could insert that. So let's go to the this one, right? Do I have to share that one somehow? All right, so anyway, so what you have to do, let me do a clear here. What you have to do before, if you notice, you were just doing format and then bat file, right? Since I modified the code, I can also inject that, what you see here, this Perl-E print ABCD. Do you see this? I'm intentionally inserting this as an input as well into the stack, just so that I can actually work out where things are located. But it doesn't really change the original one. So then if I hit enter, as you can see, it now runs the actual code. It gives us the directory listing, and it gives, I actually added PWD in there as well. Does this make sense? So this is what you're supposed to get, right? This is, you should be overcome with joy when you get this, right? So hopefully you will by next Thursday, because that's, the assignment. But it should be a very interesting thing, okay? So the fact that the book said that actually, gives us an option to work this out. So let's go ahead and let me actually show you the file. So I'm going to clear this one. And I'm going to do nano format 3. That's the one I think you guys have, correct? And so as you can see, I played with it a little bit. Basically, the heart of it is, it's got the main. It's got a couple of integers that have been there for us to change, just to see that we can write. Then it's got the secret message. It's got this buff, which is the one that stores the shell code basically, and the format string. It's got our printfs for the addresses. Then it reads 1500, right? And then you move the frame pointer. We did the frame pointer +1, but that didn't really work out. So we have to find another way. You have to debug it. Remember here we do the function call, so we get a new function in the stack, vol with buff in it, and then we go to the function, which vol buff is just basically that, a printf, and that allows us, because it's got the vulnerability, as you know, this is where the vulnerability is located. This gives us the opportunity to do the format string attack. Make sense so far? All right, so now what did I do in 5? So I basically deconstructed, format 3 from what it was to just a simple buffer overflow, so I could write things in the stack without using format string. That was my intention, so I could figure out, okay, where the problem has always been where to put the return address. Everything else we were doing it was correct. So it's just the problem is we had the wrong return address, and that's why it wouldn't work. So how do we work it out? All right, so if you notice, it's the same file. I copied the command up here, just in case so that you guys have it by reference. If you notice, before we were just doing .format and then insert bad file, right? But remember that bad file goes into standard in, but any program, if you do my program space and then something, takes values that go into argv, argc, right? And so that's what I'm doing here is I'm just adding the result of this into argv, argc, so I can have 2 inputs. One input that I can insert directly, and one input that goes into standard in as a file. Does this make sense? All right. So what is this Perl? Perl is like Python, right? So Perl is like Python, and then I use a print. And I can basically, when I do this A, B, C, D, E, F, this allows me to put any string in there. So you could put, for instance, A through C uppercase, then 1 through 9 numbers, then A through C lowercase. You can also, very importantly, insert hexadecimals in there, which means I can actually insert the address that I want in the right return address, and boom, I get the shell. Do you guys see that? So that's something that I'll show you how we can do, but it's pretty simple. Let's say that, the reason why we do A, B, C, D, E, F, all these letters is that when it errors out, for instance, if you do this in GDB, you're going to get an error called 6seg-v. And when you get that error in GDB, it tells you, I errored out because I don't recognize this address. And by the way, here it is in hexadecimal. And when you work it out that it's 40, 41, 42, well, guess what? If you look up, those are letters in the ASCII, and then you know exactly in the string where it errored out. Does that make sense? So for me, for instance, I think it would error out at around W. So at around W, I would see that those are the letters, W, whatever it follows, X, Y, Z, that were written to the return address. And therefore it errors out. Does that make sense? Once you know that, then what do? You can insert the address of where you want to jump to, which is the address of where the buffer has the shell code, right? So in this case, let's say that ours was BF, FF, CC5C. I want to insert that address. What do? 5C, it's got to be flipped. CC, FF, BF. Does this make sense? So I can actually, just by doing this, insert the actual return address that I want. And just by moving the letters, adding more letters, I can put it exactly where I want to in the return address. Is this clear, guys? So this is a way that now we are not doing, because this is format string attack, we can't do the attack like this, right? We can't jump to the code by inserting this. I only did that because, okay, I wanted to figure out where the return address was. Once I figured that out, that I could jump through this method, then I went ahead and removed it, just left it like that, and that just puts a value in a variable, but it doesn't matter. It doesn't have any bearing on the layout of the stack or the attack. We still need to achieve the attack by bad file. And the printf statement. Is this clear, the command, guys? Are there any questions before I move on? That's right. That's right. These are actually 2 attacks. the first one without bad file would be the standard buffer overflow. And then the format string is when we insert the bad file. I just did this because the return address was the thing that has given us all this trouble that we couldn't really find where it was. And I don't know that you guys are going to be at the same place that I am. You know what I mean? So I can't just say, oh, yeah, by the way, return address, guess what? It's just buff minus 24. I can't really say that, 24 bytes. And so you're going to have to figure it out. But this is a way to figure it out easily. Clear? All right. Very, very important. Okay. I'll kind of come back to it, but I just wanted to stress it out. So then we have, so that's the command. As you saw me, you can play with it. At the end, once you figure it out, just do A, B, C, D, F. As I said, doesn't matter. Let's look at our code. So if you notice, I took out a lot of the printfs that weren't necessary. It doesn't do anything, but I just always like readable code. So then we have main. Now argv and argc are now being used. They were there before, but we weren't using them. Now we are. Okay, so that's really important. I left the target variable just, because buff is the same. Now we are printing here. What's really important is to print buff because we know that buff is in the stack. So instead of doing frame pointer +1 to get the return address, I ended up just saying, you know what? I'm going to take buffer's address, which is where the shell script is, and I'm going to work my way back. So instead, it's going to be, instead of frame pointer +1, now for the return address, I did buffer minus however many bytes. So it's got to be 4 times the number of %x's that we do until we arrive at the return address place. Does that make sense, guys? Any questions about that? All right, so anyway, so buff will be useful. You can just use the link that I gave you for the calculator. That solves it. All right, so then we've got our usual reading from standard in. So that's that one. Frame pointer, this we don't need, but I just left it in there because they are variables in the stack. So I didn't want to change too much of it. And then here's now this function, notice I did change it in the sense that the function now takes 2 arguments instead of 1. Because I need that argv1 so I can pass the input from the terminal. Make sense? That Perl part. And then I do print the target here, and that's it. So you can see that's, so now we go to vulnerable function. And you can see vulnerable function takes str, which is what contains the shell code. And then there's this one, which is the Perl script with the letters A, B, C, D. So I can figure it out. So now, before, all we had in here was printf, right? Now, for me to be able to write something in the stack, I had to, because this is a function, vol f is a function. If I put a local variable called char buffer 10, what's going to happen? It gets written on the stack, correct? Is this recording? Do you guys know how this? I can tell if this. Where? The little, that means I'm recording? Okay. I'm just making sure that you guys, I'll create this video for you guys. All right. So anyway, so I was saying, so for me to be able to insert something in this stack, because what I want to do is insert something in this stack. I know it's going to override a lot of it, including the return address, and I can literally get to where we have the format string, no ops, and shell code, right? So I literally could overwrite everything. And that's actually pretty handy. It's actually, for me at least, it's the most intuitive way for me to figure out the layout of the stack. And so I created this variable. Notice it's not that very big, buffer 10, but I used the function string copy. String copy is an unsafe function because it doesn't care the size of the target. It takes whatever the input is and writes to it. So in this case, the buffer, this one, notice it's different from buff, right? So there's 2 variables here. Buffer 10 is only of size 10, but it's going to copy whatever I provide here in the argv, right? Whatever, literally. And that's the classic buffer overflow vulnerability. So I actually used that to figure it out. So then I I'm going to plug in those values, and then as big as the input is, that's how much it'll get overwritten in the stack. Make sense? And then after that, we have our printf, which is what gives us the opportunity to do the format string attack. Because remember, we have to write the address to memory, but we have to write it through the format string, which means we still need to use those %hn, %hn. Is this clear for everyone, guys? Any questions? All right, so if you notice, format 5 is literally the same file, right? It's literally nothing changes, but this is actually helpful to figure out the layout. All right, so now that that's done, right? Then I'm gonna close this. Did I change? So what are the things that we're gonna do? First of all, you can compile. Notice that all the countermeasures that we remove, obviously randomization, so you should remove randomization. And then notice that these are the countermeasures, the ones we've been using all semester. fno stack protector, that you need that to be able to run things, because those are things that the compiler tries to add to programs to ensure buffer overflows don't happen. Remember, we're doing M32 for 32-bit computers, and XX stack, all of that, right? And then just create format 5.c. All right, guys? Okay, so now let's do the, so I'm gonna compile it. Okay. Now I don't know if the layout has changed or not. Could be, but it runs. So it hasn't changed, right? We have it static, we have it not randomized. So when we run the attack now, we're able to run the code, the shell code. Basically, what does this mean? It means that we inserted the address in the right place and jump to it. Do you guys see that? All right, so what now, how can you figure it out? So the way to figure it out, and one particular thing that I do here is, if we look at the Python script, right? Exploit. Go to exploit.py. So let's open it. All right, so if you can see here, let's go to the top. We have our shellcode 32. This is the one that I've been playing with. To convince yourself, add a command. So you can see I added pwd, which is not in there. Just add any other command from Linux in there that you would type on the terminal and see that it actually does run it, for instance. I was playing with this, but it may not be the right shellcode to get the terminal. However, remember, for this lab, my goal is not so much, to get the terminal right away. We'll get it in next week. Now, I should say though, if you really want to get that terminal, just look up one of the PDFs. Okay, I'm pretty sure in either the book or one of the PDFs will have the shell code, and you just plug it in here. Or do that. I encourage you guys to do just that by the end of today. That would be great. All right, so now that we have, so that's clear, I think, for everyone. So I just want to confirm everything. So notice I'm using 1500 for the size of the buffer. Remember, we initialized the content to noops, shell 32. I'm putting at the very end the shell code, so n minus length of shell code, and then we add it in. So all of this is pretty much the same. Now, this is the part that's critical. What is this address? So this address, now notice how when I do the Perl script, I have to insert it inverted, right? But here, because it's doing this down here, we don't have to worry about it. So it's actually quite convenient to write it like this. So basically, we have to break the one address that is the one address. We have to break it into, it writes 4 bytes. We have to break it into 2-byte writes, right? Because HN only writes 2 bytes. So we need to find basically the address, and then to that address we add 2. And we can use our website that we were using before, right? So really, all you need to do is find this one. If you find this one, right, then you just go to the website +2 decimal, and it'll give you this one over here. And now you have the two addresses that you need to insert, or where you need to insert. Is this clear for everyone? So then the question is, the fundamental question is, what is this one? Okay, what I ended up doing to figure this one out is finding the address of buffer. Remember, the buffer where we are storing the format string no op shellcode. Actually, the program that format5.c just prints it out for you. Okay, so grab that address, whatever it is. So address of buff. And for me, it was minus 4, which is because each one of those, every time a %x moves, is 4 bytes. So it's basically 4 times however many %x's you need to go from buff to the return address. You guys see that? That's it basically. So it's going to be, you know, that let's just call it question mark for now, because that's where you need the Perl script. The Perl script gives you where the return address goes. And then you just figure out how many of those you move, and then it's that many times 4. Is this clear, guys? This part? Are there any questions? So it's basically buff minus whatever that is. Buff minus that gives you the address, and then the address +2. This is probably the trickiest part, because getting that data right, you know, requires a lot of. I'm not hearing any questions, so I assume you guys get what I'm saying here. All right, so then once we do this, you know, we just copy the addresses just like we were doing before. That hasn't changed. Then we scroll down here. I'll skip this part for now. Let me just finish up down here. So basically here we just have the S, right? We encode it, FMT, write it to content, and then write to file, right? So no mystery there. You guys get that? So really then we just have to focus on this section here, okay? So if you notice, this section here just basically has 2 things. This one, when I use that one, I comment out this one, and I use this mostly for exploration. Whenever I want to get a feel for where I am, where are things located, I use that one. When I actually want to launch the attack, I comment out this one and I enable this one. Remember, this is the format string attack, right? So we move, remember how it works. We've explained this, right? We have the stack. We've got all these elements in the stack. We need to move through it. So we move, we use the %x here, right, to move, but we need to figure out this number. This number may not be the same for you than it is for me. Okay, you gotta figure it out. Got it? But it's gonna be close, I have no doubt. Then that number, remember, there's an additional %x so that we can do this increment, right? So increment that number, and that's gonna be the number that allows us to write the first part of the address, FFF, the 4 Fs. Okay, play with that number. Okay, so you know, decrease it by 300. See that the letter is going to be FF down in the range. Add more, and it's going to be FF, you know, in the range. But really, you need that address. Then remember, this is the one. This puts us there, and then this one grabs the address at that place, right? Which is these addresses above, and writes to that address. So that way we write the first FFF part. Then after that, we need this. What is this for? So that we can write more, right? Because the next one is going to be a different one. Let's say CCBC or something like that. All right. And that's why we put in those percentages up here so that we have something to move through on the stack. Okay. And then here we just write the quantity again. So basically, if you remember, this is I've explained this several times. This is just to move and then write to the stack. The key thing is probably figuring out what this number is. These values, I think, will probably work out for you guys the same as me, because I'll just write FFF and whatever the address. My address, where I wanted to jump in the stack, remember what I did. Well, how did we calculate where we wanted to jump? Again, buff plus 160. Remember that? So my address ended up being like FF, CC5, 5C, I think it was. But it could, if you do 160, that's why the knob sled is really helpful, because we don't have to be very precise with it. Got it, guys? All right, so let's see what I mean by this. Before we run the attack, we actually just want to explore, right? We just want to explore. So just use this one, because this one, if you notice, is %x times 18. It means that it's only navigating through the stack, not writing to it. This is important because remember, if you overwrite something incorrectly, you get segmentation fault, right? Because there's a place where an address was expected. So at least with this one, you don't have to write, and therefore you're not going to get a segmentation fault, and therefore you should have a sense of what's going on. All right, so let's do that. So I've saved the file. So now I'm going to go ahead and do the Python script part. All right, so I did that. And now I'm going to compile again just to make sure for format 5. So that's compiled. And then now I'm going to do the attack, right? So bad file, remember, only reads from the stack, and we can insert values into it. So this is the tilde, the little squiggly line, then a Perl, and then print, and then here is where we can insert whatever we want to get a feel for what's going on. So let's go ahead and run it. And you can see this runs. The output is basically this one over here. And here we have all the things. Buffer is really the thing that we need, right? So we're going to do either this one minus 24 or so to find the place of the address of the return address, or this one plus 160 to find where we have the shell code. Make sense? Okay. Then over here, now this is what's important for you to figure out the layout. Okay. Remember, I did 18 because, we're always kind of driven, right? Where everything for us is relative to where these @ signs are. Remember, 40, 40, 40, the thing I just highlighted here is the @ signs, right? The 4 @ signs that we inserted. What does that mean? It means that we have an address here, right? That's one of the addresses. And then this one at the other end of 40, I just didn't have enough. If I had an additional %x, I would have seen that address as well. Right, guys? All right. So then, which one of these is the return address? I know already because I went through the painstaking task of trying every single one. But it turns out, I think the return address is probably either this one or that one. Okay? It's one of the two. So you have to figure it out by using the Perl script. It is not, however, this one. And one of the problems that happens is that if you overwrite this one, you get segmentation fault. But it's not segmentation fault related to the return address. It's a different kind of segmentation fault because probably it's trying to read something there and it doesn't find it. Do you guys see that? So it's not that one, actually. It is this one. Or that one. I know now because it starts at 08. I'll show you how to figure that out in a second. But let's say that you figured it out, all right? And you said, oh, it's this one, right? Let's say that you said, oh, it's that one. Then how do you figure out? So now you know where the return address is, but you still need the address of the return address. Do you see that? And that's what I said. So now how do you find it? Well, you know the address where buff starts, right? Buff is the variable that contains the shell, the format string, the no-ops, and the shellcode. So tell me, you know that address. Where is that address in this here? Where is the address of buff? Where does it start? Where does buff start here? Perfect, right? Just before the 40s, right? The one before the 40s is the first address. Do you see that? So that means that this period here, basically, you can think of it that way, is the address this one. So FF, CBB4, CBB4 is this here. Great, because if that's the case, and you know that return address is this one over here, you can now do the math easily. How do you do it? 1, 1, 2, 3, 4, 5, 6, 7, and so on. Do you see that? So that's basically what you can do. So it would be that address minus that times 4. We'll give you the new address. Okay. It could also be this one. You see this one here? So right now I'm giving you a hint that it's one of these 08 ones. So let's see that one. So if this is here, so this is 1, 2, 3, 4, 5, 6. So then how do I do it? I would say FFFF CBB4, which is the buffer's address, minus 6 times 4. And then just in the website, just do that arithmetic, and then you should hopefully have the address. And then just do address plus 2, because you're going to write both parts with the HN percentage. Is this clear, guys? This is probably one of the trickiest parts, but it should work out for you. Got it? Questions? Now, the question is, all right, that's how you figure out the address, right? That's how I figure it out so I can put it in the Python script. But how did you know that it was that one and not this one and not that one and so on, right? So that's the other question. So then you can sort of do that by trial and error. Okay, so how would we do that? So we could try. Now here, remember that this is going to write into the stack. So let's do this. All right, so why do I say that I wrote A, B, C, D, E, F into the stack? Well, look, somewhere in here, we have to have those letters. So look at this pattern, 42, 41, 40. You see that? And then over here, it goes backwards, right? So remember, 43, 44, 45, 46. You guys see that? What is 46? What is hex 46 in ASCII? What letter? F, the last one, right? So that means that we wrote until here. We did not write this one. You see that? It was not overwritten. I probably did this intentionally because I think it errors out when you do this. Okay? But you can continue then. Now that means, let's say that so let's see. I want to say that this one is this one. Let's say that this one is return address, right? So what do I need to do? In there, I need to, now think about it. I want to jump to FF, CC, 5C, right? We've determined that's buff plus 160 somewhere in the knob slit. I want to jump there. So in theory, I want to write that address in there, in that highlighted element. Do you guys see that? I know that I can get as far as 46 right now. So all I need is a few more letters and I'll get to put the address where I want it to be. Do you see? All right, so let's try that. So I'm going to notice this is currently, I'm not injecting with the format string. I'm only going to inject in another way, but I just want to figure out if I'm correct. So what do I do? Well, I'm going to, first of all, the address. How do you write the address? So remember, you have to write the address like this, but inverted, right? So I'm going to do, what is it? 5C, right? 5C is the last element. This one is CC. Then this one is what? FF. And I think this is FF, right? That's the address inverted. FF, 5C. No, sorry. FF. This is 5C. Sorry. 5C. So this is CC. Is this clear? I'm writing the address, hopefully to this spot. The problem is right now, that's not the right place. right? I'm gonna actually, if I do this command like this, it'll probably write it in here. You see that? And that also looks like an address, which is dangerous because it could be an address, just not a return address. So if I run this, it'll probably do segmentation false. So let's do that. It didn't. Okay. Did it write it though? I keep thinking that's not the right address. Is that the right address? Oh no, it's CC5C. Yeah, so sorry about it. Sorry about that. It's because of the inversion. FF. CC5C, right? So I had it, yeah, sorry. So it's CC5C. Yeah, it can, yeah. Okay, I think it's like that. All right, so let's try it again. All right, so I basically here I prove that I can write to it, right? However, if you guys notice, it didn't jump to the shellcode, right? So I'm allowed to write in there, but I did not overwrite the return address. So my guess is that the return address is around, it's this one. So what do? Add more letters. Wouldn't you agree? So A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V maybe? So you got to do the math, right? So how many? So it would be, each one of these takes 4 letters, right? So it's 4, 8, 12, 16, right? 16 letters. So I'm not sure if I added 16 letters there, but you got to be precise, or it will segmentation fault. So let's do it. See that? It worked. Do you guys understand? So I inserted the address into the right return address the roundabout way. Why did I do that? This is an actual attack, actually, called a buffer overflow. But for the format string, we are not allowed to do it like this. Therefore, what I only did it to figure out where I want to be. So I know exactly now, right? So I know exactly where I want to be. So then all I have to do is scroll up here and we determine it is definitely this one. Do you guys agree it's definitely that one? All right, so then we know that buff starts here because that's the first address, and then there's the 40s, the @ signs, right? So FFFF CBB4 is, let's say, this period. So now just work your way back to this one. So again, it's going to be 1, 2, 3, 4, 5, 6. 6 times 4, 24. So therefore, it's going to be FFF CBB4 minus 24. That will give you the address. So now we can go. I'm going to open up my my computer here. So now we can go to this Python, right? And in Python, we need to put the address. So it's going to be this one. So this is then 4 minus 6, which is 24. So now, what was that address? Let's look at it. Right, we have it there. So I'm going to do binary calculator. So FFFF CBB4 minus 24 decimal is FFFF CB9C. And there it is, FFFF CB9C. You see that? And then remember, because we're not using the %n, which writes 4 bytes, instead we're using the %hn, which writes 2 bytes, we now have to increase this by 2. So now I'm going to take FFFF CB9C plus 2, and that's going to give me CB9E. So now I have my 2 addresses in there perfectly. So I have my 2 addresses, which are going to be in the stack. So now I'm ready to figure out, I don't need this one anymore per se, right? Instead, I'm going to use just that one. Remember that now I'm ready for the format string to just iterate on the stack 15 times plus one more 16 times, really. And then it's going to be exactly at this at where we inserted that address, basically at the start of buff. And at that address, we write %HN. Try these numbers. They were always the same number, regardless of how I did it. So I assume that's FF. And actually, if you go to the calculator, what you can do is just type FFFF, right, in the calculator. And one trick I do is I just do -0. And when you do -0, it actually tells you the number 65,535. Do you know what I mean? So like if I do, right, maybe I need to share this. So if we go to the hex calculator, FF -0, right? Calculate, and it gives you 65,535. You see that? That's the number decimal. So really, share now this one. It's 60. You know, it's not that number because we've already printed out some characters, right? So we have to kind of take those out, and then that's the value, and hopefully that'll give us our FFFF in there. And that's it, guys. That's it. So really, now you just have to play with, is it 15, right? You know, because you need to get to the address there. And then that should give you the code or bash or the terminal. I think that's it. Am I missing anything? Are there any questions, I should say? Now, let me just go back. So now that we've debugged everything, right? So we did this, it works, we've debugged it. Remember, you can't really do the attack with this one, so you have to get rid of it, right? So you have to get rid of it. So now by removing this, we're no longer inserting the address into the stack. And by doing, and if you just remember, the buffer is size 10 or 20, right? So just make sure you don't have that many characters in there. Just leave like A, B, C, D, and then you're just basically writing into the buff without affecting anything. You see that point? So just, you know, I just do this so that I write something to it, but without now causing any kind of problem. And really, everything is coming from bad file now. Right, so now we're going to go ahead and do the Python again. All right, I did that. So let's see. Now I do the format. And there you go. So is this clear, guys, how to do this? You think so? Is there anything else that you want me to demo? Because I'll stop the video in a sec if there isn't. If there's anything else you want to see. And then basically, Dakota, you said if we just modify this one, we should get the terminal, right? Line 14. So get rid of it?
Yeah, I mean, you can if you need it. If there's a certain command you have to type in, you have to actually use it.
Oh, really? Okay.
It establishes a persistent
Mm-hmm.
connection.
Let me just try it out, I guess, since I'm doing it. So I'm going to change the name of this one to just bash or something. And then what I would do probably is just I would just do that probably. Then down here, this you have to play with. That's not required. Since I have it here, I don't want to do it. So then I have to do that one. No such file. Yeah, so I'll have to think about this one, but I just think we just need to provide a better shell code than the one I have. Anyway, so just change this back to change it back to 32. And we'll work on that problem later, okay? So for now, I really just want you to get this part here. Right, so this is the output for this lab, guys. So by the way, this lab is now assigned and it is due a week from today, okay? So it'll be due on Thursday. It is assigned, but all I'm looking for is this. Obviously, it's gotta be on your own machine, so you gotta figure it out. All right. Well, provide enough evidence to show me that you did it, yeah. Are there any questions? No? Is it crystal clear? All right, so I'm gonna stop the recording then, okay? And then we're just gonna have like, you can ask questions. So let me stop sharing. It was recording. All right, so I'm gonna stop it now.